Good day, classy. Thank you again. We are meeting on paper one. This is our last session of the year. I want you to note something. This paper that we are working on today, it is an additional paper. It's an additional paper. As you can see, I'm saying that it's an additional paper, which means to say that from the preparatory papers that were written, this one is the additional one. It was a reserve paper for Gauteng 2025. So I just want to urge you to be patient and follow up with us through the paper. So without wasting any time, I just want to let you see through what we are going to talk about or what we are going to look at. Climate and weather, which is climatology. We are going to talk about urban heat islands. We are going to talk about synoptic weather maps. We are going to talk about the mid-latitude cyclone. We are going to talk about traveling disturbances that are caused also because of cyclones. We are going to look at microclimate, looking at aspect, the direction through which a slope is facing. I'm sure that there are quite a lot of questions that comes on there. We are going to talk about graded and ungraded river stream under geomorphology, which is quite an interesting topic. The balancing of erosion and deposition within a river stream, the longitudinal section of the river channel. We are going to look at landforms or fluvial landforms that are formed along the river course, which are also depositional and erosional features. River capture, I'm not gonna go deep into it. It has been done severally, also as a video on content on its own, and also even on past question papers. We have done quite a lot of work on river capture. We are going to look at catchment area management, and then all these are going to be discussed today. So please just be patient. We talk about drainage density and stream order. Stream order, I'm sure that you know very well that it is one of the areas which some of you have got problems with. But right now, you are meeting with the best presenter and with the best lecturer of the time, where we are going to show and where I'm going to illustrate to you how do we calculate stream order and all these other drainage density factors. We're going to work them all out. Synoptic weather map, and I'm sure that that is going to be so interesting. So without wasting any time, please note that you always have to read the instructions. So for now, because of time factor, I want us to quickly go on the onto our paper and work out all the questions that are coming in there. So please don't forget that before you start anything, you must be able to read instructions, follow instructions per question, instructions per section, instructions on the paper as a whole. So we are given that the sketch here, which we are supposed to write only the word or words next to the question numbers. This is late afternoon temperature that is shown, and we are given urban heat island, or we can say urban delimitation. I'm sure for some of you, you really understand and you are quite aware of the urban zoning. How do we how do we see urban planning? How is urban planning done? So we have got the A, which is the central business district, and we also have different models that can be used to explain this. So please go as well, look on sector model, concentric models that are used in order to explain urban land use. So the sketch shows a dash pollution dome. What is shown in this is showing an urban heat island. An urban heat island is the one that is being shown by this diagram, which we have got. You see, this is because we see temperature is given here, and we are saying temperature is high. Temperature is high in the city center. High temperatures in CBD or in urban areas. So therefore, when we look at that, it actually explains what urban heat island, the decrease of temperature from the city center going to the rural folk. So we call that urban heat what? Urban heat island. It is an urban heat island that is being shown in this case. This is the correct answer, urban heat island. Pollution doom, it is also one of the other microclimate concept that I want you to understand, that we also have the concentration of greenhouse gases that tend also to be highly concentrated in in urban areas than the rural areas because of factors that have to do with human activities. So what I want you to understand here is that look on the check on metric hub that is given this explanations on urban heat island and pollution doom. The line showing temperature on the sketch is dash. Here what needs to be understood is that on we also gonna say that this can be attributed to a synoptic weather map where we use specific types of lines that are used to illustrate and show a weather phenomenon. So isotherms are the ones that is the one that is used to show places or places of the same temperature. We call that, or the temperature variation of a given piece of land at a given time. It's called isotherm. Isoheads, this one, it connects places of the same rainfall, totals. We call that what isohead. Isohead is actually for rainfall. And then don't forget again, we have got what is called isobars. Isobars are for the same pressure. We are saying isotherms, isohead, isobars. They are lines that are found on the map, which are there to identify places of the same pressure. Is isobars. Isohead is rainfall. Isotherm is what? Is temperature. And then A or B experiences less precipitation. A or B experiences less precipitation. We are looking at this. I'm sure that when you look at urban climate, you need to understand and explain the variation in rainfall totals. I mean, in the two regions that are given. So we are saying this is in urban areas. We are saying rainfall totals in urban areas versus in the rural areas. Rural areas. In urban areas, we tend to have high rainfall, and then we have got low rainfall, low rainfall in what? In rural areas. This also has been explained on Metric Hub. There is a nice video that explains this. So we have got less precipitation in the rural areas, which is marked by what? Which is marked by B. This is rural areas. They have got less rainfall compared to the urban areas. So what happens is that in urban areas we have got a lot of hydroscopic molecules or moisture molecules that are found in the atmosphere, which tend to facilitate condensation, unlike in rural areas. In urban areas, I'm sure that you'll see that quite a lot of times we have got high rainfalls in what? In urban areas than in rural areas, which is caused by a multiple factors that has also been explained in Metric Hub on one of the videos on microclimate. At A or B is an increased surface area that can absorb heat. So when you look at urban heat island, we are going to, you need to understand what are the weather factors that you can explain that vary in terms of the rural and the urban. So at A or B is an increased surface area that can absorb heat. So we have got an absorption of heat because we are saying in this area, we have got high artificial surfaces, high artificial surfaces, which are, we can say, concrete surfaces, which also tend to increase what? Which tend to increase temperature. The reason why you see here on the isotherm line that is shown here, you see that the temperature is high there. It's because at A, we have got artificial surfaces. We have got also artificial heating. I'm sure you know in urban areas, we talk about aircon systems that are used in heating and cooling, which are also attributing or contributing towards high temperatures. So it is at A where we have got increased surface area that absorb heat. It is A, which is the urban area, which is the urban areas. We have got urban areas that increase the heating, and then artificial heat is produced at what I have already mentioned that already here now that I said high artificial surfaces that are found at what at A. They are found at A, so artificial surface, artificial heat is produced at A. This is because we are saying at A in urban areas we have got artificial heat, which we are talking about the electricity. We talk about the geysers. We talk about air cons. We talk about all these artificial forms of heating that are used in urban areas unlike in rural areas. So we are saying, or we need to understand that artificial heat is produced in urban what in urban areas than in rural areas. Reduced visibility because of smog will be experienced at reduced visibility. We are saying reduced visibility. We are talking about the ability to see. We are talking about the ability to see, visibility, ability to see clearly. So it is not there. It means we are not able to see clearly at which place because of smoke. I'm sure you have seen that in urban areas, we tend to have some form of smoke that is found, which also tend to be uh, affecting visibility. So our answer is what is A, which is urban areas. And then people who experience heat stress and even die during heat waves at what I think that the 7 marks that were given here were designed just to make sure that we can boost our marks. It is also in urban areas. Urban areas will have to people experience heat stress and even die during heat waves. We have got heat waves that can also be found stressing and suffocating people in urban areas. So therefore, it is A. We are given question 1.2, synoptic chart. Synoptic chart, I want you to understand this class. We can also say synoptic weather map. It can also be called synoptic weather map. It is a weather map that is drawn, or that is it's a chart or a map which where symbols are used to represent weather factors. We have seen that all the weather factors have got standard symbols that are used in order for them, I mean, in order to represent them. For example, H represent high pressure. We can say H represent high, it represents high pressure. We say L means what? Low pressure. We can also talk about triangles that are resting on the line, which means what? A cold front. And then we also have uh, which also means it means also tropical cyclones. Tropical tropical cyclones. What I want you to understand is that a synoptic weather map, it uses symbols to represent weather phenomenon or weather factors. So these symbols are given there. And then one thing before I go anywhere, I want you to understand that in any given time, a synoptic weather map will show the time in which it was developed or it was captured. So that can also come as a question which you are going to be asked the season. When was it then the map was done? So we look at the season and the time. We are saying 2024, uh, 14 January 2024. This is the date It is very important in understanding synoptic weather map, so therefore you can be able to know it was in winter or it was in summer. You know your seasons as according to your country. And then now, first question reads that okay, before I go anywhere again, you need to know that these are called contour lines. Contour lines are these lines that are drawn, which you can see like black lines that you are seeing on the map here. These are called contour lines. They join places of the same altitude. We are saying they are used to measure what? Altitude. They identify places of the same altitude, which means to say that we are able to see the terrain, we are able to understand the landscape. Either to say it is a steep, it is a gentle slope or whatsoever. So the more the lines are spaced, the more gentle the place or the place is. When the contours are too closely packed together, it shows that it's a steep place which you can identify that that is because there is a very sharp variation in terms of that landscape appearance. So therefore, the more spaced the contours, the more gentle a landscape is. If it is dominated by one contour line, you might find out that sometimes you find a place that is just dominated by one contour line. We are saying if the contour line that is filling up this, if the space is filled up by one contour line, we call that this place is equally flat. That would mean to say that the landscape is actually flat. It will show a flat landscape. Therefore, we can say that is a what? A peneplain. That can be called a peneplain. What can be the factors that might result in the formation of those? So what I want you to know is that contour lines are good in understanding landform features that are found in different places. Which season is represented on the synoptic chart? Which season is represented on the synoptic chart? As you can see, I said that the season date gives us the season. The date gives us the season. So as you can see, 14 January, it is what? 14 January, it shows what? This is what? This is summer. In January, we are in summer because of the date there. I'm saying this is because of 14 01 24. It shows that this was in what? In summer. And then which identified the pressure cell at 1. Pressure cell at 1, we need to look for 1 and identify which pressure cell is it. Where is 1 on the map? We need to look for 1 and then identify the pressure cell that is at 1. We see 2 is here. This is 2. This is 3. That is 4. And then we are looking for 1 on the map. Pressure cell that is represented. They identified the pressure cell at 1. So what I can say is that you need to understand that what you need to understand is pressure cells are identified by L and H. Let's say if it is given with an L at the center and we say this is a low pressure cell, that means a low pressure, cell. And again, if it is like this and then we have H on the center, it means a high pressure cell. It means a high pressure cell. So now what you need to know is that if we look at this, you should be able to understand that H, it means we have the highest pressure at the center, and then it can decrease as we go outside. I can say maybe if we have H here, then we can say 10, 20 here, and then the next isobar here can be 10, 16, 10, 16, and then the next can be 10, 14. So this is identifying that would means this is a high pressure cell. So unlike on a low pressure cell, we can have we can say 10 we can say 10 20, and then we can have the next one coming, which can be, which we can say it's gonna be 10 24. We can see the other one coming, which can be 10 26. So what I'm saying is the low pressure is found at the center. We have the low pressure at the center. It means it's a low pressure cell. But if we have got high pressure, which is at the center, it means it's a high pressure cell. So what you need to know is that air moves, or the circulation of air is determined by pressure, whereby air moves in from high pressure to low pressure, which I also agree that you can be able to go and check on the channel. There is quite some good notes that explains high pressure cell systems and low pressure systems in terms of the air circulation, whether in southern hemisphere and northern hemisphere, clockwise and anti-clockwise motion according to the hemisphere in which the air is moving. So please go and read and check on that again. It's quite interesting, which we can also not have to fail when you go to exams. So now we want to see the next question is saying, will the wind at 2 blow faster or slower than at 4? Wind at 2, it will be wind at 2 blower. Okay, you see our one which is here, I was just missing out that one. One is a low pressure cell. This is low pressure because you see there is that L there. One is a low pressure which is given there. My eyes were just deceived. That is one. One is just showing there it's a low pressure cell. As you see that L that is given here, this L is showing that it's a low pressure. So the question next is saying, will wind at 2 blow faster or slower than at 4? Wind at 2 will blow faster or slower than at 4. So at 2, we are saying 2 is here. Our 2 is here. This is our 2. And then we say our 4 is there. So what is happening is we have got a steep gradient and a gentle gradient. So now what you need to understand is that wind will blow faster at 2 than at 4 because of the gradient. We are saying wind will blow faster. Wind will blow faster at 2 than 4 because of the landscape at 2, because of the landscape at 2, which is steep. I'm saying 2 is a steep gradient. It has got a steep gradient, so the wind blows faster at 2 than at 4 because of the landscape, because of a steep landscape, or because of a steep gradient that we tend to find at 2 there. There is that variation. I have mentioned that you'll see here we have got we are saying there is the terrain which is showing that the landscape is more gentle and 2 is on a very steep landscape. So what I'm saying is the steeper the landscape, also the more it also affects air movement. And then what is the general direction of movement of the system at 3? What is the general direction of movement at 3? Number 4. What is the general direction of movement at 3? At 3, we need to identify the general direction of movement at 3, which we just need to identify. Our 3 is here. The general direction of movement at 3 here. At 3, we are saying the direction of movement, it is actually going to be in which motion. At 3, as you can see, we are saying the general direction of movement, it can actually be from east to what? To west, which is because we are saying this is also affected with regards to the landscape that you are seeing there, we have got, we are saying it moves from east to west. It is a tropical cyclone that is being shown there. So the direction it is supposed to move from what? From east to west. East to west. And then in which stage of development is the system at 3? At which stage of development is the system at 3? What is happening is that we can be able to tell that also by the shapes of the contours. The contours are actually showing that the cyclone has been fully developed. We can actually see that cyclone symbol that I'm saying that it is shown there. So the cyclone symbol which is showing there is showing that this is a tropical cyclone that has been fully developed. So it actually shows a mature stage of a cyclone. It shows a mature stage. It actually shows a mature stage. It actually shows a mature stage of the cyclone, which is shown because of the symbol there. And also you can see those contours are equally flat, showing that they have already reached the last stage of development. Explain the atmospheric conditions at the system center at 3. So we are saying at the system center at 3, we are talking about at the center of a tropical cyclone. What are the atmospheric conditions at the center of a tropical cyclone? You'll find out that we're saying at 3 there, the atmospheric conditions that are at the center. I'm sure that you know that we have got some kind of cumulonimbus cloud that forms the walls on both sides, and then at the center we have got we have got cloudless conditions which are caused because of the descending air. When the air is falling at the center there, it is actually causing it results in cloudless weather conditions. It is cloudless, it is very calm, very calm, very calm weather conditions. We have got very calm, we have got cloudless conditions, very calm, and then we also have no rainfall, no rainfall. 83. We are saying why is that so? It's because of dissenting warm air. The air that is in there. I'm sure class you remember that this is shown by a diagram which is something like this. We have got a diagram which is something like this. We have got a diagram that shows something like this, which we said that it actually shows that there is convergence of air in the atmosphere and then divergence, which is happening in the what? There is convergence. This is convergence in the atmosphere, and then we have got divergence, which takes place also on the lower atmosphere. But what is happening, or what is happening here, there is no rainfall here because there is the descending air, the descending warm air, it is dry because of warm descending air, which is dry. No rainfall can form in that area, or no rainfall can be found in that region. So please take note. You can as well be able to connect and follow from what from the channel. We have had some nice presentation that are there explaining some of these that we are talking about. And then number 80, why would the stage at 3 dissect as it moves over land? Why will it dissect as it moves over land? It is because we have got we are saying it is what happens there. Why would why would the system 83 dissect as it moves over land? It is because remember that we're saying how what causes a cyclone to die when it reaches the land. It is because of the friction which is found on the surface. Frictional surfacing, frictional surfacing. It actually slows down. It slows down the system. We also have problems to do with there is supply of moisture which is no longer there. We are saying there is moisture is cut off. Moisture supply is cut off. Remember, we said that for it to continue happening, there must be latent heat of vaporization that is there, which is also supplying the energy for the cyclone to keep going. So moisture supply, if it is cut off, we have got problems to do with what there is possibilities of the disruption of the cyclone over the land because there is no energy that can sustain it. And then there is also cooler air from there is also the possibility of cooler air that flows into the cyclone, increasing the pressure uh, flowing in of cooler air that increases the what? That increases the pressure. So now what we are saying is that these are the reasons which can cause the cyclone to dissect when it moves over the land. It can cause the cyclone to dissect as it moves over the land, and then we can be able to understand that these are the reasons which actually are sustaining, or I mean, they are actually causing conditions that are dying out, dissecting, meaning to say we are saying dying out, or we are saying fading away. That's some of the things that I want you to look at, and then let's just go to the next question. It's an infographic of mid-latitude cyclone, which is also given 18, 18 July 2024. And also, we are saying another cold front expected to influence the Western Cape today with scattered to widespread rainfall. The rest of the country can expect fine, cool to warm conditions. And then advisory, be aware, disruptive rainfall is expected. Warning, valid Thursday, 18 July until Thursday, 18 July 12 minutes, I mean a minute to 12. Affected areas are given here. There is Drakensberg, Drakenstein, we have got Stellenbosch, we have got all these associated hazards, localized flooding, susceptible, formal and informal settlements and minor motor vehicle accidents due to slippery roads. We talk about reduced visibility can be expected. People can have problems. Longer travel times are also likely on major roads, and then localized disruption of essential services and localized land mudslides, and also rockfalls are possible. These are conditions that are caused because of the mid-latitude cyclone that has been forecast in this case. So we are given occluded fronts that are given on the map here, and the question is saying identify the fronts that, I mean, fronts at, identify the fronts at 1 and 2 on the synoptic map. 1 and 2 on the synoptic map. 1 and 2, I can see 2 is here. 1 and 2, so we have got 1 here. This is a chord front. How do we know that it's a chord front? Because of the triangles that are resting on top of the curved line. So 1 is a chord front. 1 is chord front, and then 2, as you can see, it's a home front. We are saying the shapes that are here, they represent a home, and this one represents a chord. So what is happening is that this 1 is a chord front, 2 is a home front. That is what you need to take note of. Why do cold fronts affect Western Cape in the winter season? Cold fronts, they affect Western Cape in winter season. What is the reason? It is 1, the northward movement of the wind belt move north in winter. I'm sure that we have seen that the wind belt, actually the wind belt moves north in winter. It moves north. It moves north in winter, and then at the mid-latitude cyclone, mid-latitude, mid-latitude cyclone, the mid-latitude cyclone moves from west to east. That is also, then it passes through Western Cape in winter. Mid-latitude cyclone moves. It moves from west to east, moves from west to east in winter. Hence it passes through Western Cape. That is one reason that you should understand. So what is happening is that there is a northward movement of the anticyclones in the winter. The anticyclonic conditions, they move north in winter, is one of the understandings that you should have with regards to factors affecting South African weather. What is it that affects South African weather? We are saying in winter, the wind belt, it moves north, and then which we are talking about, that is the anticyclonic circulation that moves northwards in winter. That is the reason. And then what do we call mid-latitude cyclones that occur one after one, that occurs after each other, like the ones on the synoptic map? When mid-latitude cyclone occurs in series one after the other, they are called family. They are called family. They are called family of cyclones. They are called family of cyclones because they are occurring one after the other. They are called family of cyclones. They do occur one after the other. We have got, as we are seeing on the map there, we are saying one mid-latitude cyclone occurs, and then after another one occurs. We call that family cyclones. And then explain why mid-latitude cyclones cause hazardous conditions that are indicated in the warning notice. Mid-latitude cyclones, they cause hazardous conditions that are indicated in the warning notice. What is happening is because there is always torrential heavy rainfall that is associated with it, resulting in flooding. Flooding occurs. Hazardous conditions are caused because of one, possibilities of flooding due to torrential heavy rainfall. Torrential heavy rainfall, it is causing that. it causes the possibilities of that. We have got chances of flooding that are caused because of heavy rainfall. So we can have problems that are indicated in the map here that we are going to have affected areas which are going to suffer localized flooding, and also accidents that are also caused because slippery roads will be slippery, and also traffic congestion which is caused also, which we also have to experience localized mudslides and rock falls. They are caused because of the lubrication that is caused because of rainfall. And then the other reason is also because snowfall and ice will cause the roads to be what? To be slippery. Snowfall, snowfall, snowfall and ice. The snowfall and ice will cause roads to be slippery. Roads will be slippery because I guess you have seen the issue of accidents that is identified in the scenario there. It's because of conditions such as those. And then we also maybe possibly need to talk about rainfall will cause limited visibility for drivers. Drivers are affected in terms of visibility because of rainfall. Because of the rainfall can also affect that. So what I want you to understand is that these are the situations which are resultant from hazardous conditions as a result of what of mid-latitude cyclone. We have got situations such as those that I have mentioned here, which we need to understand that they are causing the situation that we are to talk about. Discuss the positive impact of mid-latitude cyclone on environment of the Western Cape. What are the positive impact of mid-latitude cyclone on the environment of Western Cape? One, we can talk about development of good animal pastures because of heavy rainfall, because of heavy rainfall. So the heavy rainfall will actually cause the farmers, can also cause the people of Western Cape to have animals that are good, that are healthy. We also have there is also continuous supply, continuous filling up of water resources in order to ensure availability of water in dams, in rivers, for both human and animals. So in other words, what I want you to understand is that water resources are replenished. Water resources are being added up with water that can be, as you know, water is a scarce resource. So when it rains, it means that there is also condition that can also understand, or that can also increase livelihoods of people in those areas. We also have production of winter crops results in good food security. Production of winter crops. Farmers can engage in winter crops, winter cropping will enhance food security for the country. So what happens is that farmers are able to grow winter crops that can be able to sustain lives of people, such that we are able to do away with the hunger. And then all these are good advantages that we can talk about. We can even relate to the issue to do with harvesting of rooftop water harvesting can be done in order to sustain and also conserve our natural waters that should be used instead of using our groundwater. People can also harvest water. Rooftop water harvesting can be done from the heavy rains that can be experienced in winter, such that people can also be saved from problems to do with water shortages. That can also be an advantage. The sketch below, which illustrates traveling disturbances. We have got traveling disturbances that are given here. And then we have one question is that as it is given here now, it is actually asking, like I said last time, that when you are given synoptic weather maps, you are supposed also to understand questions that can arise, which can be able to say that which ones, what is happening? Is it winter? Is it winter? Is it summer? And all these, it is possible to understand that based on synoptic weather maps. So which seasons are depicted in sketches A and B? As we can see at A, we are saying we have got anticyclonic circulation, which indicates that we have got what A is showing summer. As you can see, this anticyclonic circulation, which are circulating in this with the arrows that are shown there. So what we need to understand again is that we have got we also have rainfall that is, or rainfall and lightning that is showing within the interior of the country. So what is happening is that rainfall, we can have it in what? In summer. And then obviously B, we have got B, which is actually therefore representing winter. B is therefore representing winter. How is the air circulation around the high pressure cell in sketch B? How is the air circulation around the pressure cell uh, in sketch B? In sketch B, what happens is that we have got the high pressure cell, which is given here. I said HP represents high pressure cell. So in sketch B, how is the air circulation? Air movement is actually, remember that we can say this is in southern hemisphere. So what happens there is that there is an anti-clockwise air movement. We are saying anti-clockwise. There is anti-cycle. We have got anti-clockwise, anti-clockwise air movement. Anti-clockwise air movement is what is taking place in what? In sketch B, we are saying what happens is that in southern hemisphere, anticyclonic or when air is moving in the from the high pressure cell, it moves in an anti-clockwise direction. This is a theoretical understanding that just has to be built by a metric student, understanding that pressure cells that I've been talking about, to say northern and southern hemisphere, how does it affect the air movement, or how is the air movement? A high pressure cell in southern hemisphere, we have got an anticyclonic or anti-clockwise air circulation. Anti-clockwise air circulation. Explain why conditions are different in the interior of South Africa in both sketches. We are saying the conditions are different within the borders. We are saying inside South Africa, the conditions are different, and then I explain why conditions are different in both sketches. So what we need to talk about sketch A. In sketch A here, sketch A, the invasion layer is weakened, allowing that it allows the invasion layer is weakened, which actually allowing which is actually allowing the advection of warm air into the area, resulting in in rain over South Africa. I remember that when we talk about anticyclonic circulation and we talk about the issues of the invasion layer affecting, we say the invasion layer, we talk about a zone or a level of warm air that is found on top of cold air. Instead of saying the higher you go, the cooler it becomes, it says the higher you go, the warmer it becomes. So therefore, an invasion layer in sketch A, in sketch A, sketch A, sketch A, which we are seeing there, the sketch A, the invasion layer is weakened, which is allowing the rainfall that we are seeing there. We have got rainfall here. We have rainfall. What is the reason? Because of the weakening of the invasion layer. Sketch A, invasion layer is weakened. Actually, what happens is that the invasion layer will blanket or will avoid the ascending warm moist air to rise within the interior, or it would stop rainfall to form because the warm moist air that must get inside is actually stopped. So in sketch A, invasion layer is weakened, allowing what? Allowing the advection of warm air into the interior is weakened, allowing warm moist air, warm moist air. It is allowing warm moist air into the interior. And then which results in rainfall, which causes rainfall in South Africa. It causes rainfall in South Africa. In sketch B, as you can see, sketch B, what happens in sketch B here, there is no rainfall. We have got, we need to understand that there is strong subsidence, or a strong subsidence blocks the advection of warm air into the interior, which results in dry conditions over the interior of the country. So we are saying there is a blockage of warm moist air into the interior, which actually causes dry weather conditions. As you can see there, we can see there is dry weather conditions that we are seeing here, which are caused because of the blockage of advection, almost air that must get into the interior of the country. So sketch B, we need to understand that strong subsidence, strong falling down of warm air it blocks it blocks the advection of warm moist air, blocks the advection of warm moist air, the warm moist air that it cannot reach, which warm moist air into the interior of the country. into the interior of the country. So what happens is that which obviously results in dry conditions, resulting in dry weather conditions in the interior of South Africa. Interior of South Africa. As you can see that the interior of South Africa, we don't have rainfall. We have no rainfall in there. It is because of the strong subsidence of warm air, which is now causing or blocking rising warm moist air to reach into the interior of the country, so that when the warm moist air is blocked, it means it cannot reach the interior. Therefore, dry weather conditions can be found experiencing dry weather conditions can be found dominating and being experienced within the interior of the country. And then question 1.4, explain how line thunderstorms develop. Sketch A, explain how line thunderstorms are developed at 1. We see that there is line thunderstorms that are there. What causes the development of line thunderstorms? Line thunderstorms, what causes the development of line thunderstorms? So what we need to understand is that when thermal low pressure and coastal low pressure cells are located over South Africa, this results in a low pressure trough that feeds warm moist air to the interior from the northeast, and then warm air converges with cold dry air from the southeast. Cold air, it actually lifts the warm air which cools adiabatically, as to say it cools with a degree of every 100 meters rise. So what we need to understand is that condensation takes place and forms some tall cumulonimbus clouds that are associated with thunderstorms, heavy rainfall, and possibly we have got hail. So these are the conditions that we can talk about. We can talk about it is because of it results in we have to talk about thermal low pressure, thermal low pressure, and coastal low pressure. And coastal low pressure cells are located over South Africa. Are located over South Africa. They are located over South Africa. So what happens is that they result in low pressure trough. It results in low pressure trough that feeds warm moist air. Low pressure trough that feeds warm moist air. They feeds warm moist air to the interior from the northeast. Warm moist air to the interior. Where does it come from? It comes from northeast. From northeast. So almost air converges with cold dry air from the southeast. Almost air converges. It means the meat converges. It converges with cold dry air from the southeast. Converges with cold cold dry air from southeast. So cold air lifts the warm air, which results, we are saying warm air is lifted. Warm air is lifted, resulting in the formation of cumulonimbus clouds. Warm air is lifted, causing cumulonimbus clouds. The cumulonimbus clouds, they are associated with heavy rainfall. They are associated with heavy rains and thunder and lightning. Thunder and lightning. So what you just need to understand is that there is the upliftment of warm west air, which is actually causing cumulonimbus clouds to form. And the cumulonimbus clouds, you know that they are associated with heavy rains. The heavy rains also accompanies with what? With thunder and lightning. That is, now we talk about the line thunderstorms that we need to talk, or that are being referred in this case. And then next question is saying, refer to sketch B, discuss the negative impact of the wind at the weather station at 2. Weather station at 2, the wind at weather station at 2. We have got a a northwest wind movement, which is moving at what? At 30 knots as given there. The wind is moving at 30 knots. So now what is asked is that we need to know what is the effect of these strong winds. One, we need to understand that the strong winds can actually cause veiled fires. Veiled fires impact the natural environment, affecting. This can cause a rapid spreading of veiled fires, affecting both animals and plants, affecting plants and animals. Plants and animals can die because of the what? Because of the strong winds that are there, that are spreading the fires. You know, we have got runaway fires that are associated with this weather condition, which we are saying high temperatures with no rainfall can result in what? Can result in such conditions. So what we need to understand is that a rapid fires can spread rapidly because of that. We can also talk about animals and houses can be lost. Farmers can lose animals, equipment, and property. It can be lost because of those fires. We can also talk about the destruction of habitat, destruction. The fires can actually destroy habitats, which also resulting in loss of biodiversity, loss of biodiversity, like our natural ecosystems can be affected because of the fires that we are talking about. And then we have got health hazards or health conditions, health problems, and distress which can cause high death rate of people. People can die because of these heat waves. The heat waves can cause stress, stroke, and all this discomfort. And then, obviously, I can as well maybe want to mention the issue of dehydration in both plants and animals. They can suffer from dehydration, which can cause them to what? To dry. Dehydration of both plants and animals can be also another problem that we can see. We are given a sketch here that illustrates cross-section of south-facing and north-facing slopes. We are given this, we have the sun here. If you can remember this question class, it has been given severally. We are repeating it once again. It just needs to relate to the concept of aspect. How is the issue of aspect affecting the various effects or the economic conditions or economic activities of people when we look at the north and south facing slopes with regards to solar and solar orientation. So the first question is saying this is the north and that is the south as given on the map here. So the question is saying explain the concept of slope aspect. It is the direction through which the slope is facing. Aspect is the direction to which a slope faces. We are saying it is the orientation of the sun in relation to the slope. So as you can see, we are seeing here when the sun is hitting the earth, how much amount of sun is able to reach, how much amount of sun is able to reach and hit the slopes here. The orientation, these arrows are showing orientation. The arrows are showing orientation. This is the issue of orientation that I'm referring to. The aspect of how much incoming solar radiation can be able to hit up the slope. So that is what we call aspect. We are saying give the direction which, the hemisphere, which hemisphere does the cross-section represent? The cross-section is representing a southern hemisphere, which is showing the north-facing slopes receiving more sunlight than the south-facing. We are saying the north-facing slopes receiving more sunlight than the south-facing slopes. So it is the southern hemisphere. It is the southern hemisphere. We are saying it is the southern hemisphere, as we can see that more sunlight is oriented to the north-facing slopes. We are saying the issue of the slope and the sunlight is that the slopes that are facing the north, they receive more sunlight than the ones facing the south. Hence, we talk about the idea of housing. People tend to build houses on the slopes which are facing the north because of natural heating of the sun, and also other human activities can be able to take place, which is unlike in the shadow zone where the slope is facing is always in the shadow. Hence no rain, no sunlight is experienced. So account for the location of the village in the cross section. The location account for the location of the village in the cross section. Actually, as you can see, we are seeing the village is on the north facing slope. This is the village that we are talking about. It is on the north facing slope. So what happens is that village is on north-facing slope, is on north-facing slope. It is on north-facing slope. What happens there? Because there are warmer in the southern hemisphere, they are warmer in southern hemisphere. In southern hemisphere, what happens is that they are warmer in southern hemisphere, so they receive since they receive maximum sunlight. I think that you can see it by my arrows that I've been drawing there. There is more sunlight that is coming to the north-facing slopes. More sunlight is coming towards the north-facing slopes in southern hemisphere. So there is natural heating which is there. So it actually it is actually in that position to avoid. It is actually is located in that region in order to avoid uh, cold conditions, in order to avoid cold conditions, uh, cold conditions that are that can be possibly cold conditions during the night. Cold conditions during the night. So the houses must be put or must be located in this zone in order to allow natural heating and also direct sunlight, and also at the middle of the slope where there is maximum incoming solar light or solar radiation. And then in a paragraph of 8, discuss why Area K is not ideal for settlement. Area K, this one, we are saying Area K, it is not ideal. It is not ideal for settlement. We have got fields that are in the what? In the shadow zone there. It is in the shadow zone. So what we need to understand is that this is a shadow zone, which is Area K. Area K is in the shadow zone, which we can say that it's a frost pocket. It's a frost pocket. So what happens is that the area is too cold. It's too cold for human settlement. It is too cold for human settlement. What happens is that cold air drains down. The actual cold air drains down the valley slopes, which actually we are saying which can affect farmers if frost sensitive crops are also grown, which may affect farming if frost sensitive crops are grown in the area. So what we need to understand is that if we are talking about it is actually there are possibilities of frost that can develop in Area K, because of it is the valley floor which is vulnerable to what? To frost. So Frost sensitive crops must not be grown also in that area. We can actually have ice, which we can say there can be ice on the floor or on the roads with moisture and slippery surfaces, which also might be causing accidents, and it is prone to what? It is prone to flooding. The area is vulnerable to flooding and may have slippery roads, which may cause accidents. Hence, we are saying people cannot stay in the area because it is dangerous to stay there. We may have slippery roads that can be caused because of frosting, that can be caused because of icing, and therefore accidents are very vulnerable, which can make it inhabitable for people, which can make it not safe for people to stay there. We are saying there is frost there that can occur in area K because it is a frosty pocket which can cause floors to be slippery or roads to be slippery, and also crops can die in that area. So farming may not take place there, not unless the farmers can grow frost-sensitive crops there. So these are the reasons that we can see that they do affect the whole point that we are to explain in this respect. And then we are given drainage density below, geomorphology. We are given geomorphology here, drainage density that is given. So this question, as you can see, is one of the nice questions which you must also maximize. So let's see that we can otherwise just want to answer the question that are given there. Choose the correct statement below that matches the drainage basin above. So we have got drainage basin A and B that are given. So we're saying the drainage basin has soils with little moisture and high infiltration. It has got soils with little moisture and high infiltration. You know what happens, ne? Drainage density is affected by geology, underlying landscape, and also antecedent moisture. So drainage density, we're talking about the manifestation of streams over or within a drainage basin. So we have here, what happens is that A can suit that to say soils with little moisture and high infiltration, therefore results in what? It results in low drainage density. So it is a drainage basin with little vegetation cover. Drainage basin with little vegetation cover, it results in more runoff. What happens is that we have got more runoff. The runoff causes what? Causes more streams to form. More streams can develop, and therefore that can be a drainage basin that is what? That is B. B can be the one which have got high drainage density. Absence of vegetation cover can cause high drainage density. So it is B. Drainage basin with gentle slopes. Gentle slopes can also, we are saying gentle slopes can also result in more infiltration and less runoff. This can also, the concept is about the ability or the possibilities of streams to form. So in this case, we have got few streams develop here. We have got few streams develop. So we have got develop in this area. So we have got low drainage density, which means that it is A, and then drainage basin with high porosity and high permeability. Porosity is the ability of water, rainwater, to fill into the ground, and also even permeability, the ability of water to infiltrate into the ground. So we say that A can also do on number 4 because it causes low drainage density. And then a drainage basin with low evaporation, number 5, drainage basin with low evaporation. Low evaporation will cause soil saturation. It will cause saturation, and then saturation will result in more runoff. It results in more runoff, and then we have got high drainage density. We will have high density developing in that. So where do we find that? We can find it in what? Where we have got more streams, that is B. That is B. And then drainage basin with steep slopes. Steep slopes will also cause rapid runoff, high density. So B can also do, because we result in what? In high density. It results in high density. Therefore, we have got what? We have got streams forming there. And then the density drainage basin has low porosity and low permeability, which is also the opposite of question 1.4, is the opposite of this one, which means it is what? It is B again, because it has got high drainage density. Drainage basin with high evaporation rate obviously is the opposite of that one, which is number 80, which means that it must be what? With high evaporation density, it means it must be, we are saying drainage basin with low porosity, and number 80, it must be, it must be what? It must be A, which we say that drainage basin with high evaporation rate, with high evaporation rate, it causes more water to infiltrate, and then low density. It has got low density. Low density therefore develops in a situation where we have got what? A. Low density can cause A to form. And then we want to look on river profiles that are given. This question, I once answered it before. It is just that to show you that if you revise, you are able to master and pass these questions. A and B, graded and ungraded river channel. That is what you can see. We are saying when it is graded, it is a smooth concave shape. It is smooth. There is no obstacles. And then this one, it is actually ridged. And then we have got also waterfalls that are there. Waterfalls that are there. So this one is ungraded. And then this one is what is graded. That is one thing that you should know. It is all about the erosive power or erosive capacity of the streams that are given in this case. So which of the profiles above is graded? Graded is B. And then which profile is dominated by either erosion or deposition? Which profile is dominated by neither? Okay, there is no erosion or deposition, which means that there is no erosion, there is no deposition. It means it results in an ungraded stream, which is A. And then profile shows evidence of turbulent flow. Turbulent flow, we find it in an ungraded stream, which is A again. It is A. And then which profile has a balance between erosion and deposition? We found it in a what? We are saying number 4, it is actually found in a graded stream. When there is a balance between erosion and deposition, it results in a graded stream, which is what? Which is B. And then which profile will have temporary base levels? Temporary base levels, these are, we are saying temporary, they are the permanent base level is the C. So these ones are found because of landforms that are found along the river channel. So number 5, we must understand that temporary base levels are found in an ungraded stream. Ungraded stream is where we have this, which is a ungraded stream is found, which profile shows evidence of headward erosion. Evidence of headward erosion, number 6, it is also found in what? In A, which we say this we can say rapids or whatever here, or waterfalls. They cause the migration of the stream eroding back towards the source here. There is a backward erosion which takes place. So it is found also in A. And then which profile has less erosion? Less erosion, it is also found in a graded stream which is smooth. There is a smooth flow here. A smooth flow results in what? In absence of erosion or less erosion, which is what? Which is B. Which is B, can be found there. These are fluvial landforms that are shown below. Fluvial landforms that are shown. We see this is our stream, and then we have got A marking some landforms, and then B also marking some landforms. So now, what we need to understand is that they are what are called floodplain. It is actually found as deposits. Floodplain, we are saying the floodplain, they can actually be found on the river channel, which I'm saying that these are depositional features which we must be able to understand. And then natural levees is a natural embankment. So floodplain is actually found along the river banks, and then the upliftment of the river banks, it is artificial leaves, or I mean it's called levees that are found as a result of that. So now let's see the question. What does the question say? Identify fluvial features labeled A and B. So we are saying A, as you can see, A is illustrating. I said these are the levees, and then this is a floodplain. A floodplain is a depositional feature which is also found towards the sea, where material is laid off, and then it accumulates there, and then the embankment that we are seeing is the levees or levees that are shown here. They actually show depositional features which tend to increase the river banks. It is the levees. And then the next question is saying in which course of the river can both these landforms be found? We found depositional features in the lower course of the river channel. Lower course of the river channel is where we find that. And then where will be lighter? Where will the lighter and smaller load be deposited at feature B? Where will the lighter and smaller load be deposited at feature B? Where would they be deposited at feature B? When we look at feature B, we are saying what happens is that light and smaller load is dropped further away from the river banks. The lighter and smaller load or sediments are deposited away from away from the riverbed, because they are light. They can be carried far further than that. So lighter and smaller load are deposited. They are deposited further away from the river banks, are deposited further away from the river banks. It is because the river has got the capacity to carry them further away. They are lighter, and then as you can see in a floodplain, the light material are deposited further away from the river banks, because of the energy and the capacity of the stream to carry them further away there. And then explain explain how fluvial feature A is formed. Fluvial feature A, we said that the fluvial feature A, the leaves, how are leaves formed? How are the leaves formed? We are saying these are the leaves. We are saying there is repeated flooding of the river forms the leaves. They are formed as repeated flooding. Repeated flooding causes leaves to develop, and then cause in which we have got we need to understand that biggest and most coarse material will be deposited first. Biggest or most coarse, most heavy materials are deposited first. They are deposited first, and then they are the ones which will be deposited first. This will be close to the which will cause them to accumulate. They accumulate close to the river bank. They accumulate close to the river bank. What happens is that because they are heavy, the river cannot carry them. So they are deposited close to the river banks because of the weight. We are saying the heavier the material, the higher the chances of deposition. So because they are heavy and big, the river capacity or velocity can therefore lay them off first close to the river bank, and they accumulate close to the river banks there. And then the banks form levees made of sediments, silt, and other material. The banks form levees that are made of levees of sediments. Sediments, we are talking about the material which the river was carrying. Sediments, which is made up of silty, finer material, silty, and other material. That is what happens in terms of this. They are formed because of continuous flooding, which causes the levees to develop, carrying material and depositing it along the river banks, and then they accumulate with the time like that. And then 2.35, discuss the significance of the fluvial feature A. The artificial, this we can talk about this, is it increases the river banks. So one, levees, they help to prevent flooding. They help to prevent flooding. As you can see here, we are saying the river banks, as water accumulates, it rises here. As water rises, the banks are continuously increasing as of the materials are accumulating there. So we are having an we are having an embankment increasing. This is embankment which is taking place there. And then we are saying it helps to prevent flooding. And also we can also talk about We also have the fertile soils that are suitable, create fertile landscape. Landscape that is good for agriculture, good for agricultural, agric purposes. That is good for agric purposes. Um, it can also increases um, availability of land for other organisms, habitation, for habitation of various organisms. There are quite such ways that we need to understand. River capture class, I have done this severally. I think, can you understand and accept that it has been severally done, river capture? This is done, uh, check check previous videos. Check previous videos. We have talked about to say this is the misfit. We talked about that. This is the misfit, is the wind gap, or it is alluvial deposit, is the elbow of capture, elbow of capture. We have talked about this is the capturing stream and all these things, watershed and all that. So what is happening is here, see, we have got headward erosion occurring there, headward erosion, and it is what? It is more erosive. We are saying it is adjusting towards that, and then it takes this. So in terms of river capture, I want you to understand and appreciate that we have done this one severally, and then can we please just go and check on that? Number 2.4, river capture definition. I cannot define that. We talk about the filling of the headwaters of each of another river, and then we said that, like I said here, I talked about headward erosion or obstruction is the one causing process. What process of responsible is what? It's obstruction. I says it's obstruction or headward erosion. Headward erosion, when erosion takes place adjusting towards the source of the stream. What evidence of river capture will find at elbow of capture, wind gap? We are saying it has got, in terms of that, I have given you that last time that we have got gravel accumulation, and then we are also seeing the pirating or the joining of the weaker stream that takes place. Uh, this whole question, it is done. It is just referred to the channel. It was done properly there. Just check and also relate. Go on Metric Hub. It was done nicely there. Let's go and check on it. In terms of catchment area management, this we have also, it was also done. We talk about catchment area management. We have talked about that and well explained that to say what is catchment area management. Explain how the polluted or affect communities. That was done. We talk about issues to do with shortage of water due to pollution. Communities will not have access to clean water. We talk about people having diseases that are diarrhea. We talk about waterborne diseases that are born from that. So those are the diseases that we can mention there. So I guess this is enough and we can call it a day, because we've worked out all these questions. It's just a repetition of all the questions that we have done before. So thank you very much for your time and all the best in these upcoming exams. I'm going to come up with network questions, GIS and so forth. They are going to be synthesized, bring them together, or make a compilation that is going to be uploaded soon. Just look forward to that. And also your paper 2 is coming. Thank you very much and all the best. Let's keep on connected and sharing until we meet again. Have a good time and thank you, thank you, thank you.